So let's recap. This is factorial. This is also permutation. Okay. And then we talk about the generalized version. That is this. This actually is multinomial coefficient. They are R thing. If R is 2, you have N1, N2. That is binomial. We haven't talked about what's binomial because first we have something called combination. Combination means order doesn't matter. Permutation, orders matter. So you can think of permutation is like 1 by 1. Combination is like I take these three, I don't care about the order. So that's the idea. Or you make a funny story. For me, it's the Joe Biden, Mike Tyson story. Okay, so you see this symbol. You may write NCR. No, now we always write bracket. Because later on, we will have other bracket. 5 choose 3, 5 factorial, 5 minus 3 factorial, divided by 3 factorial. So how do you understand this thing? Is this thing. 5 choose 3, right? Assume these 5 are different object. How many permutation? 5 factorial. This. What about the thing in the bottom? I choose red box and white box. All the red box are the same red box. I don't care their order. So how many ways can I permute the red box? I have 3 red box. So number of type 1, that means number of red box is 3. 3 factorial. Number of white box is type 2 object. White box is the second type. So how many of them? 2. 2 factorial. So 5 factorial divided by 3 factorial divided by 2 factorial. That means what? If you understand permutation with repeated element, you actually automatically understand what the heck is binomial coefficient. Because multinomial is a more general version of binomial coefficient. This is just what? This is just multinomial with the multi becomes 2. Okay, I repeat this many times. Combinatorics, this kind of mathematics. The answer is just a simple number. It's not like calculus, you have to write a lot of crazy formula to write the answer. In the end, it's just some simple number. But from here to here, it's not calculation of a lot of things. It's the idea, understanding. So you need to understand what the heck this 3 symbol mean. What does the 5 factorial mean? 5 factorial, where does factorial come from? Factorial come from permutation, right? So therefore, it means how many ways you can permute something. And then what? Why there's a division? Division from the previous slide, these 3 examples. This is to tell you we double count something, so we have to disregard the double count, so that's why we have division. So therefore, in binomial, this line have a meaning. It means among these number of permutation, we have double count something, so we disregard those double count things. Then that means the thing below are those things with double count, we have to remove them. Then now what the heck these 2 things mean? 2 factorial, 3 factorial means what? How many permutation for a stuff that have 2 elements, and how many permutation for another stuff that have 3 elements? What does the 2, 3 come from? This 3 red box and the 2 red box has the meaning of this 2 fact and 3 fact. You need to understand at this level. Why? Because later on, we will have this kind of thing. If you don't understand this very clearly, when you see sterling number, you mess up. That's why you really need to understand everything. That means what? That means if I draw a chicken here, you need to understand why there's a chicken here. If I draw a line here, you need to understand what's the meaning of the line. My point is, do not underestimate how this is, I learned in high school easy. Yeah, if it's easy, why don't you go to Math Olympiad? Yeah, not joking. Let me show you now. I call it exercise, math book, because after you finish the exercise, you become math. Okay. So this is the math book. This module last year is called 1215. This is the combinatorics exercise. There are 20 something, okay? And then difficult problem in combinatorics come from Mathematical Olympiad. You may know, Mathematical Olympiad basically for high school or year 1 student or even some primary school, Terry Tao, AESO. Why they can solve this? Because they understand all the symbol in an expression. And if you think this, oh, it's just 5, 4, 3, 2, 1, 3, and then 2, 1. Yeah, you are knowing this number. You are not understanding what the heck is going on in the expression. That's a bad thing. And this makes you no different from ChatGPT. I've repeated this so many times. That's why whenever you see an expression, please try to understand every symbol, even a line. A line has a meaning. I'm telling you this because this is very important. If I am a bad person, I can skip all this and then just tell you all the formula and you just memorize all the formula like a table, done. But that's not learning. So these are basic property from the binomial coefficient. How do you prove this? You can prove them algebraically by writing down expression, by writing down factorial and then show it. But actually, in this case, I would say this picture tells a lot of things. So this picture proves everything. You don't even need to write it. But in some case, this kind of thing now is not trivial. For example, okay, let's say this one is called Vandermonde convolution. How do I prove this? Well, you can prove it by using the definition like this. But I can tell you, if you do that for this one, your proof will be crazily long. And because the proof is crazily long, very easy you get mistake. That's why last time I talked about combinatorial proof. And I can tell you, this one, you know how to prove it by combinatorial proof. Why? Because this is sum rule. What the heck is sum rule? Let me come back to the example. This is what I talked about last time. You want to prove this. So what does this mean? Among 4 N ball, pick 2 ball. That's the meaning. What the heck is this? This is saying, for the 4 N ball, these 4 N ball are all black ball. No color. what I'm doing here is that among these 4 N ball, I paint the ball. I can paint 2 N of them are red, N of them are blue, and N of them are green. I paint ball do not change physics, right? It's still the 4 N ball, right? So now if I pick 2 ball among this red, green, blue, if I have a way to find the number of ways to pick 2 ball from here, it should give me the same thing as 4N choose 2, right? That's the idea how we prove this kind of thing. So I need to what? Apply some rule. What? Branch, grow a tree. I have this 3 thing, and I need to pick 2 ball. So that means what? The first ball can be red, the first ball can be blue, and the first ball can be green. So you have 3 branches. And then now you have the second layer. You also branch 3 times. For each of the case, in the first case, you branch 3 more branches, the red, green, blue. Then that you get this. What is this? You have 2 ball, both of them are red. Then how many ways? 2 N choose 2. 2 ball, both of them are blue. How many ways? You have N ball, right? N choose 2. 2 ball are both green. How many ways? N choose 2. And then 1 red, 1 blue. But now we don't care about order. That's why it's not permutation, it's combination. So we have this. And then 1 red, 1 green, and 1 blue, 1 green. You have these. Then all of this is what? Some rule. These are all the possible way you can pick. Then you have this. Then what? This is the same thing. So I have a 2 here. And then now I just have these. So you write down the factorial notation. Then and you simplify the math a little bit. Then you get an N squared. Then this sum together give you 5N squared. So you have this expression. And since this second counting is just counting the same 4N ball, I just paint them with some specific color. I don't change physics. So it's the same 4N ball. Of course, they have to be equal. That's it. If you understand this, I can tell you, you can prove van der Waals. Now, you have R plus S ball. You want to pick N ball. Let's say R is 1 million, S is 10. Okay? So among 1 million plus 10 ball, pick N ball. N is just a number N. I can now split this N into 2 numbers. One is K, and one is the remaining N minus K, right? Then what? What does this mean? This means I pick what? K ball from the 1 million. This means what? I pick the remaining required ball from this S amount of ball. And what is this sum? This is all the possible way I can do this. Equal. That means what? You prove this by argument in 2 sentences. You don't even need to write this kind of thing. If you understand this. So what I did here, I repeat again. I count it by the first way, and I count it by the second way. They are both the same thing. I didn't change the physics. I just paint them with some color. It's the same thing. So left equal, right equal. Same technique here. This looks very complicated, right? No, it's just some rule. Same technique here, same technique here, same technique everything. That means what? That means, I told you, do not underestimate this kind of symbol. If you understand the meaning, you have the skill to come up with this kind of combinatorial proof. Okay? But I'm telling you a good news. This is just, I let you know this kind of thing exists. I'm not going to test you in exam. I'm not going to test you in midterm or assignment or homework, blah, blah, blah. I just let you know. Now, let's go to second example. I want to prove this. Okay? This is some rule. Now you should feel, whenever you have a plus, this is some rule. And whenever you have something multiply each other, it's Cartesian product. And whenever you have something divide something, you are disregarding double counter thing. So now suppose I want to count this. You make up a story. So suppose I have what? A set S. I call these people. And then I call them A, B, C, D, E, F, G up to Z. I assume they are N plus 1. Okay? Then what? What is this thing? This thing means there are this number of ways to pick this number of people, right? So you have N plus 1 people, and you want to pick K plus 1 people, then this is the binomial coefficient. The hard part is, of course, this part. So now, this is the trick. Notice that what I do previously. I paint them with some color. This is the idea. Okay, imagine this person, E, is so important, I call it VIP. Then what? We now do the same thing. We also select K plus 1 people in the set. This is the same as what? I pick 2 balls without a paint, and I pick 2 balls with a paint. Now, this is the same. The first way is I pick K plus 1 people. The second way is also I pick K plus 1 people. But now one person is VIP. So now I'm going to do what? Consider all the possible way I can do this. With what? With respect to this special person. So, if you select these people, K plus 1, you only have 2 ways, right? Grow a tree in your brain. Either you pick this person or either you didn't pick this person, right? So you have these 2 bullet points. This bullet point is saying that this VIP is selected among this K plus 1. The second bullet point is this VIP is not selected in this K plus 1, right? Then what's next? Now I have grown the tree, first layer tree. I branch 2 branch. One is VIP is among the selected people. The other branch is it is not in the selected people. Then I need to do what next? I fill in the tree. I told this in lecture 1. Whenever you think you grow a tree, you don't need to make the tree perfect, but you need to have the biggest branch. Then you fill in the small branch. So now suppose the E is selected. That means what? I need to pick this number of people, but one of them is the VIP, so I just need to pick the K of them, right? So therefore, what does it mean? Among this number of people, I have selected one, called VIP. Then how many people left to select this K? This. So this means what? This bracket n choose K. You previously know that, oh, it's a binomial coefficient. Now suddenly you have a special meaning. Means what? Among n plus 1 people, choose K plus 1, but in a special situation that a VIP has been selected, I want to select the remaining K people. Suddenly this thing have a meaning. So this is what? The case VIP is selected. So this thing drop 1 because VIP is selected. This thing also drop 1 because the VIP is selected. So that's why you have this. Then what's the second case? The VIP is not selected. So how many people do I need to select? This. But how many people among the S I can select? Because I know VIP is not selected. So of course, now from n plus 1, I reduce to n. So this is the second case. And these are the only two possibilities, right? Then I sum them, sum rule. I prove this is equal. See? I don't need to do any algebra. I don't need to write any equation. Purely by combinatorial argument. This is the most interesting part in this kind of subject. And if you cannot make up with this kind of argument, doesn't matter. This is hard. You can't do it in one try. I understand. This is what I illustrate and demonstrate to you by 3 examples. This is the first one. Okay. This is the second one. And this one is the third one. And you can do it for this one, this one, this one, this one, this one. The hard part is what? The hard part is you need to come up with a story. That's why now you know why I come up with the Joe Biden, Mike Tyson. This is a story so that you understand things. So now I have 6 things. How many subsets are there? There's no rule, right? So I can just pick nothing. 1 object, 2 object, 3 object, 4 object, 5 object. So it will be this. So each object have 2 branch. Pick it or not pick it. So 2 for the second object, also 2 branch. Pick it or not pick it. 2 product rule. So that's why you have this. But if I'm talking about from this 6 member, I pick 4 things. Then 6 choose 4. That's it. Now here's another example. I have a 0, 1. That means this is my alphabet. I only have 0 and 1. There's no 2, there's no 3, there's no ABC, question mark, dollar sign, no. And now I want to form a length 10 string. That means 10 empty boxes. Inside the boxes, they are 0 or 1. But I have a condition. You need to have more than 6 ones. Then what? You can say this length 10 string have what? 6 1, exactly 6 1, 7 1, 8 1, 9 1, 10 1. Okay, this is error, wrong, but anyway. Well, mathematically it's not error because these 2 sets is the same thing, so union of them give the same thing, so mathematically is not error, but anyway. Then you have this, right? Sum rule. Why? Because all these K are disjoint, so I just add them. Then I just need to count which, this one, how many ways I can pick 6 1 from 10, 10 choose 6. How many ways I can have 8 1 among 10 box, 10 choose 8, and plus, 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 and then I have a number. See? So this one is what? Using inclusion exclusion principle and binomial and sum rule. Now, what if we have repetition, new stuff? Introduce to you this bracket. This bracket, this is defined as this. That means, what's the explanation of this equal sign? There's no explanation. This is definition. Please remember this, okay? Now, what the heck is this? This is number of ways to choose K element in n set, but repetition is allowed. So, let's look at this example. You are a farmer. Your farm only have cats and dogs. Somebody want to pick 3 pets, take 3 pets from your farm. How many ways is possible? So, you have a farm, F, only have 1 and 2. 1 is cat, 2 is dog. So, prove false. This is all the possible way with 3 pets. So, all of them are cats, all of them are dog, and then some of them are 1 cat, 1, 2 dog, and 2 dog, 1 cat, something like that, okay? So, you have this number of cases. But we are now dealing with combination. So, that means what? 1, 1, 2 and 1, 2, 1 are the same thing, so we don't care, right? 2, 1, 1 and 1, 2, 1 is all the same thing. Under this situation, if I remove all the same combination, because we don't care about order, we have this. This is different from the previous one, 5 choose 3. Why? Because you repeatedly choose something here. So this means cat, cat, dog. Cat, cat repeated. This is the case when you allow repetition. So this is 4 cases. Okay, this way is what? By brute force. Let's look at the formula. What's the formula? How many things in the farm? 3. And I want to pick 3. So K is 3. K is 3. How many things in my set? 2 things. So n is 2. So 2 plus 3 minus 1. 2 plus 3 minus 1. 5 minus 1. 4. So 4 choose 3. Now here's the first thing you need to be aware of. Nobody said this n has to be larger than k. N can be smaller than k. If you learn binomial in high school, probably most of the time n is larger than k. Nobody said n has to be larger than k. Be careful. So now you see n is smaller than k. Now here's a second example. Now you have birds. So bird, cat, dogs do the same thing. Pick 3 pets. Now you do brute force. This is a brute force. You have 27 k's. Why 3 to power 3? Branch 3 times. This is actually the same thing as the ABC, ACB, CAB thing. Okay. Then what? I'm not talking about combination. So 1, 1, 2 and 2, 1, 1 are the same thing. And also same for 1, 2, 1. So I don't care. I remove those repeated cases. So this is the cases. I have 10 of them. In this case, I pick 3 elements, right? I pick 3 pets. K is 3. K is 3. My farm have 3 type of thing. N is 3. 3 plus 3 minus 1. 3 plus 3 minus 1. Choose 3. Okay. You have bird, cat, duck, dog, 4 kind of animal. So 1, 2, 3, 4. Again, you pick 3 pets. So K is 3. N is 4. So it will be 4 plus 3 minus 1. So that means 6 choose 3. So this is the idea. Another example, you have 5 type of battery. AAA, AA, CD, and 9 volt. Okay. How many ways can you choose 20 battery? That means you can have 20 battery, all of them are AAA, or all of them are 9 volts, or some combination of them, because you allow repetition. So it's not binomial. It's this thing. Okay. What is this thing? Diamond bracket. You can think of diamond allow repetition. The curve do not allow. So it will be what? How many battery type? 5. How many battery you want? 20. 5 plus 20 minus 1 choose 20. Equal this. Lastly, there are 5 type of soda. Coca-Cola, Zero, Pepsi, whatever thing, okay? And then you buy 7 can. How many way can you choose? So 5 type plus 7 minus 1, choose 7, this. So why you have this thing? You can think of it like this. You have all the cat here, okay? All the dog here, and mix, I call it M. Right? If you do this, here's the idea. So I have 3 animal. So it's like I have 3 boxes, right? But now I allow repetition. Allow repetition is the same as I draw what? 2 bar here. What does this bar mean? First of all, this bar is exactly this number. I have 3 animal. Now I have 2 bar. This 2 bar means somehow I put 2 bar here. And then you consider this 2 bar can move. That means what? That means I can have what? Bar, here, 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 and then here, and I move. So, in other words, you can think of if I treat this bar as also a box, actually I have 5 boxes, right? So I can have this, right? So this 2 bar suddenly coming from nowhere, you can imagine is this thing. Then what the heck is this? This 2 bar is like, it's possible, what? All the box I fill is cat, all the box I fill is dog, or all the box I fill is mixed. So you can think of this bar is like what? Suppose I have this, okay, suppose I have this one, okay? Then I can put stuff. Then you can think of it as this bar is like everything before the bar is cat, everything between the bar is dog, everything after the second bar is mixed. So it's like this. You can think of this bar is what? Classifying the repetition. So what is this? What is this? This will be cat, 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 bar, bar. Because no dog, no mix. What is this? This is bar, bar, no, okay, bar, bar, dog, 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 bar. No cat, no mix, all dog. So this is the meaning of the K minus 1. This is explanation 1. This have a name called star and bar. Star and bar. If you want to Google it, you can Google this. Okay, this is called star and bar method. And then what? I'm now giving you the second explanation. Is to use this picture. Assume now I have 5 choose 3. So this is 5 choose 3. Now black is permutation. The Joe Biden, Mike Tyson thing. Red is what? 5 choose 3. I fight Joe Biden, Mike Tyson, Elon Musk at the same time. I'm doing 1 versus 3. Now, the third situation. I also fight 3 people. But I can fight Mike Tyson 3 times. So this black means I fight them 1 by 1. No repetition. Cannot reappear. I cannot fight Mike Tyson 3 times. Red means what? They all 3 appear in the boxing arena. And I do 1 versus 3. What's this thing? Imagine Mike Tyson duplicate himself 3 times, and then I do 1 versus 3, but then I have to fight 3 Mike Tyson. This is the meaning. Again, this is a story. A story is crazy. Crazy, that means stronger impression in your brain. Stronger impression in your brain, that means you have a higher chance you remember it. And I always use the Mike Tyson, Joe Biden thing, because this is a crazy story, so it's easier to understand. So therefore, how do you differentiate this? Permutation, I fight them 1 by 1, no repetition allowed. Combination, I do 1 versus 3, they cannot duplicate themselves. Combination with repetition, I also do 1 versus 3, but I can fight 3 Elon Musk or 3 Joe Biden. Okay, that's the 3 thing. You need to differentiate the 3 things. Then here are other examples. Combine everything together. I have 26 alphabet. I have a 5-letter string. No repetition is allowed. That means I cannot have A. Imagine you make a computer game character. Okay, you have to name a character and 5 letters. You cannot name it A. Okay, how many ways are possible? Again, you have many ways you can think about how to solve this. Always pick one that you feel is the most natural or comfortable to you. This is what I think. Not necessarily good for you, but I just share mine. So I have 26 letters, right? So I imagine 26 boxes. Okay, I have to form a length 5 string, right? That means I imagine I have to place 5 boxes in this 26 box. Then this action have how many ways? This number of ways. This is this picture. Then now, what? After I finish this action, I have 5 boxes. I don't care about their location anymore. Then I care about the stuff inside. Then now I care about the stuff inside. I cannot have repetition now, so this is permutation. This is 5 factorial. That's it. So therefore, these 2 things, there's a multiplication here, correspond to 2 pictures. The first picture is I have 26 boxes. I decide 5 locations to put 5 boxes. This corresponds to the first thing. The 5 factorial corresponds to the second picture. And after I do this, I decide what the stuff to fill inside. This is the second picture. Then I combine them. This is what? Cartesian product. So therefore, I have this. And then now what if the letter are, you can repeat. Well, if you have repeat, suddenly you don't need to do factorial, you just 5. Yeah, because you can do A now. You can also have B. So that means what? 3. Every time when you think about one boxes, you branch 5 times. You can have A, B, C, D, E, and then you can have A, B, C, D, E, and then A, B, C, D, E. So 5 times 5. 5 power 5. Okay. Third example. Same. First 2 letters cannot be the same. So that means you cannot have A something, B something, C something. Then you do the what? This. So first letter is 3. Second letter cannot repeat the first letter, so -1. So that's the idea. Okay. Again, but now length 7. I don't have any repetition, right? You can call somebody A. Okay. Then this is the number of length 7 English name in a video game. So now 26 letter again, length 7 English name, but you have to start with A. Then what? These are all the letters possible which come from here. This is subtraction rule. These are what? This is B, C, D, E, F, G, just not A. Then I just subtract them, right? This means what? This means first letter is B, C, D, E, F, G up to Z. What about the remaining? Freedom. Any letter I can take. So I subtract them. Let me make it clear. This kind of thing, if I talk about them 1 by 1, separately, easy. But if I mix them up, sum rule, product rule, inclusion, exclusion principle, Cartesian product, combination, permutation, with repetition, without repetition. Later on, there will be ordering, partition. Oh, so that's why this is very important. You need to understand all the symbol, all the line, even a horizontal line division have a meaning. Otherwise, you get stuck. Okay, so this. Now we come to binomial theorem. So what is binomial theorem? You have this. So expand x plus y power 3. You write something like this. Okay, maybe some of you are not comfortable with this symbol, so now let me spend a few minutes explaining this. So what is this thing? This thing means for anything here, okay, now I draw a circle here. If here I have a label I, then that means what? This means for loop. I for loop this guy from the starting point, let's say 3, to the ending point, let's say 5. Then that means what? This means I have 03, 04, and 05. This sigma is summation, so I add a plus here. Okay? I can do the same thing for big pi. Pi means product. Then if I have I equal, let's say 2 to 6, and then what? I have xi. That means what? I will have x to the power 2, x to the power 3, x to the power 4, x to the power 5, x to the power 6. Okay? These are all the x to the power. But this pi symbol means multiplication. So I multiply them. So in any way, x to the power 2 plus 3 plus 4 plus 5 plus 6. So there's no plus. So this means sum. This means product. You can also have this. Okay, this means what? A bunch of sets add up together by union. You can also have this, a bunch of sets add up together by intersection. So how do I do this? I put k equals 0 here. N is 3 because this is n, this is n, this is n, this is n, right? So 0, 3, 0, 3. This is k, k is 0, k is 0. This is n minus k. N is 3, k is 0, 3 minus 0, 3. So you do this. So that means what? This first term, how do you get this first term? You're just repeating a human for loop. You are doing a for loop. Then what about the second term? Second term is k plus 1. So 3, 1, 3, 1. X, 1, x, 1. 3 minus 1 is 2, so 2. And then you have this and this. Do not underestimate this procedure. You may think that, oh, I know binomial very well. Yeah. What about this? What about this? If I suddenly change to 3 term, 4 term, you're suddenly stuck and don't know how to do this. That means what? That means you actually don't know how to do a for loop. You are just remembering a formula. That means actually you don't understand. See my point?